Are you able to see my screen?
Yes, ma'am.
Okay. So today is the fourth live session of Geographic Information System taken by Bharat Aitan sir, IIT Kharagpur, and I am as a TA of this course. So in the last topic, I have covered data models in GIS, vector data model and raster data model. What are the types of data generation? How, like from map, from survey, ground truth information, from aerial imageries, how we are getting our photo, how we are getting the information of this data generation, and how we are importing this data in GIS software using data entry processes. What are the processes and the steps it has been taken care in terms of data entry in GIS software. Then I have covered the different data type and their sources in the India, like how the DEM and land use land cover maps, soil maps, and agriculture map, and uh, other thematic maps, how it is generating and what are the sources in India as per India. I have told. And then georeferencing system. What are the georeferencing system? What are the types of georeferencing systems? How, where we have used such kind of georeferencing system? I have spoken in the my last class. And the datum. Datum. What is datum? Is a reference point from where we are going to allocate mean sea level. From that is the reference point from where we are demarcating our projection system. And what are the types of projection system? Where I will use the cylindrical or Lambert conic or azimuthal, which kind of projection system can be used in different uh, different kind of, like what we are willing to preserve, like cone, like area we want to preserve, or shape or line or direction. So it is it is selected based upon that what what entity we are willing to preserve, that is projection system we have chosen. And then coordinate reference system, which coordinate, like geographical coordinate reference system or UTM, universe transverse mercator. So India lies in six zones of UTM, which I have told in my last class. What is the scale in map, and what are the type of scale, large scale and small scale, what are the purpose, how it how it told about the uh, detail of an imagery or map in the larger scale perspective and small scale perspective. So I have spoken these things, and the topo sheet map I have explained in my last class, from where the survey of India topo sheet map, what are the scale and characteristics in a map, I have showed in my last class. So these things have been covered. So today's topic is the GIS data quality. This week sir has covered the data quality. What are the quality and functions of the GIS datasets, how it has been taken care in terms of mapping any feature on the globe, on the earth surface. So this is the quality. The GIS data quality is just a function of intangible properties such as completeness and consistency. Completeness means like how completely it speaks about the reality over the ground. The data is completely true on the ground. What the GIS software is capturing and what is really existing on the ground is the completeness of GIS data quality. The consistency meaning where in the two, like I have selected one point, I have selected another point. What are the changes occurring in between these 2 points, and is it consistent means no change are coming for change with the time period or uh, with different temporal scale. So where there is no change, if the consistent is there, and where there is a change against consistent, then it means to say that your data is actually good. So because with the time, with the season, things are changing over the ground, if you see. So consistency deals about the changes over the ground, and completeness deals about the feature you are referring are speaking exactly the ground truth reality in the GIS or not. So completeness affect the quality of spatial data. It measures the quality, refers to the feature, their attribute and relationship with the spatial data. Means I am speaking about ground truth reality, which means related to space or spatial data layer representation in a standard form by a user. as sir told, there are different type of data layers, thematic data layers. Like if you see, as GIS is a overlay of number of thematic layer, like soil layer, road layers, population census, or land use, land cover, or drainage map. So there are different layer. So user who are working over a different data layer should represent their feature in a particular map or thematic map with a standardized form. Like every feature have their own standardized form, have told by the government, so they should follow. Or else if we are willing to match two image of the same place or for the same feature, it will show different uh, projection, or you can say different layer, which will be a error in the GIS mapping. So that's why we need to represent standard form, like by a user means us only, which are going to deal with the GIS data sets and preparing the data layers. So it should be lies in the standard form, then only it can represent the true map imagery. So data layer representation should be in a standard form. Like if you call reliability of data, it means the age of data, map scale, the resolution, the cost, and the accessibility. These all related to reliability of data. Then first I have talked about the quality of data, which consider the completeness and consistency. Completeness speaks about the spatial changes or spatial relationship with their attributes on the ground surface, and consistency deals with the if there is no changes with the time. So it will be a consistent means true, it means no change is occurring. Or reliability of data is the age, map, resolution, how it is reliable as per the data we have taken or collected in our GIS software, and how good or true representing these things over the ground with the same time frame, with the same scale or spatial frame. So GIS data quality having six key factor: the timeliness, the completeness, the uniqueness, consistency, validity, accuracy. So first thing is, as I told, completeness, degree to which necessary data is available for use. It means how much data is necessary to map any GIS feature, any feature on the Earth surface in the GIS software. So this many information should be there, should be uh, available to. So degree to which necessary data is available for use or for to prepare a map or visualize the map. And uniqueness, degree to which the data is unique and cannot mistaken for other entries. Means, as I told, see, I have a thematic layer of land use, land cover, and I am demarcating like urban land use feature, like water reason, and the agriculture reason, or urban land, or road network. So I am giving the numbering of 1 2 3 4. Like one I have given for agriculture land, second I have given for urban land, third I have given for water feature, and then fourth I have given for road network. So if you have prepared the same map, land use, land cover, but you have numbered it in different number, not the same 1 2 3 4 what feature I am allocating, so it will be, it is not unique. So our both of us map for the same reason may show different results because of random numbering or not same numbering. So that is called degree to which data is unique. If there should be uniqueness, means you also follow the same numbering or same feature, then only our result should show the same output and cannot mistaken for other entries, or other more entries cannot be changed. Like you classified some more feature other than road network, and you have considered like residential area, you have considered barren lands, you have considered the uh, fertile land or soil reason is eroded or not, this is the smooth slope profile. So you have considered some more feature, but you have numbered appropriately, then it should not be mistaken by other entries also, and it gives the uniqueness in the datasets. So that is also a key factor of the GIS data quality. The consistency means degree to which data is equal within and between the data set. Means, as I told, consistency means equality between a given reference with the time. So degree to which the data is equal within and between the data sets. Two data sets I have taken at a time. What are the same characteristics or same like I have taken one point on the road. Okay, this many traffics or this many vehicles are passing from a road cross section. Same I have taken on the another point over the road, another cross section, and there also I am counting this thing. So how much the numbering is same, like degree to which the data is equal. Here also this many traffic are going to covered, or it is diverging on the next section, or what is it. Like I just have given one example. So between two data sets, what are the equality, so it can be taken care. Or you can say there is a drainage network. So uh, the river crossing from a point where it is it is the water is approximately like this much quantity of water is sustained over the ground surface, and then it like canal is passing one section of water, then it is diverging from another section. So this section has provided 25 mld of water, another section it crosses, so this also providing another quantity or 25 or 30 mld of water. So or similar or different, so how the consistency is changing, it is remaining same or it is changing with the time, with the different space. So that is called the consistency. Validity means degree to which the data is within defined requirements like format or data type or range. So validity is the, it should be in a defined format and type or range of the values. So it should show the valid range of the data. Accuracy means degree to which data represents the reality. As I told, it should follow the ground truth reality, whatever, because GIS is Geographic Information System. When we are taking help of this GIS software to see the ground truth reality only. So how much it is accurately assessing the ground truth information in the software, it is called accuracy of the data sets. Like as I told, data sets can be taken by primary, it has primary, secondary and tertiary source. So primary source where, like as a surveyor, person is going and collecting the ground truth reality. Secondly, from the government organization or from register or from the uh, tools like web pages, we are going and collecting the data, secondary data. So it should represent the reality, how much accurately it is capturing those ground truth reality and how much it can give a reliable result. It's called accuracy of the data sets. Timeliness is degree to which the data is available at the time it is needed. Like okay, something like you consider uh, any disease or any hospital is the like patients are there which are having severe disease in a hospital. So available the timeline is okay, this much time this many patients have been recovered, and it has taken this many patients in the hospital, and lately this data sets available, uh, like degree to which the data is available at the time it is needed, and I have collected this information of this many patients, and later okay, in the another nearby hospital there are this many. So like if you see in any governmental or medical organization, they are collecting such kind of data sets with the time frame. Like when COVID also happened, so they are counting the number of patients with the okay, this many as this many times, so it is reducing or increasing with the time. So this kind of records we need. So in GIS also, this is one of the example of medical I have given. Similarly for urbanization consideration also, we need this timeline information, like for 10 year before, this is the land feature information, or this is the land use land cover information of the particular region, and the another coming year, this is the land use land cover information. So how much reliable it is, how much time with the time, how many information I am going to collect, and lately how much more modification has come into picture. Like as the things are advancing, we need we are getting more data in our hand, like using this network and things. So it is speaking about the data is available at the time when it is needed. So this is also a key factor in the GIS data quality. The probable source of error in the GIS uh, data quality are the measurement, the data encoding and entry, and data processing. Like how the error can be caused in the GIS datasets. Like what happen when we assign wrong coordinate system, which can be often done by users only like us. Like what happened, I have seen, okay, 30 degree, 40 45 minutes, and some seconds. Then I was just considering, okay, 30 degree 45 minutes, I just have mentioned another coordinate, I have mentioned few minutes or few second deviations also cause wrong georeferencing or wrong assignment of the particular feature. So that is wrong assigning of coordinate system. This is, I am speaking about georeferencing. Similarly, what happens, we have geographic coordinate system, we have UTM, universe transfer mercator, which is projected coordinate system. If we don't assign, if we are working on GPS, like sorry, GCS, geographic coordinate system, and we need to calculate the area of the particular boundary. So what happens, we don't assign the projected coordinate system, we are not able to calculate the length or the area or the thickness of the region. So that is also causing the error in our GIS data quality. And mislabeling of the area or in the thematic map, as I told about land use land cover map, like I have numbered differently and another person who worked, they have numbered differently, so it may cause mislabeling of the thematic layer. So that is also cause an error when we overlay same, when we see the both the result, we may think like, okay, your output is different, my output is different, but it's not. Because of numbering, it got changed and it got misplaced. So misplacement of horizontal or positional boundaries, like what happens when we digitize. First, I have spoken about georeferencing and coordinate system. Secondly, I have spoken about the misnumbering or labeling of the maps or layers that may also cause different output and error in the our data set. Misplacement means what happened, positioning. I am talking about on the earth surface. If a feature is located, like road is located at the particular location, and when I am or you, someone is digitizing, it got misplaced. Like we have taken another vertices or wrong points over when we were digitizing the ground truth reality on the GIS software. So what happens? This misplacement or misboundary causes the error when we calculate. It will cause like undershooting, overshooting error, slicing. I have told na other some errors also in our previous class. What are the errors in digitization? So that misplacement in horizontal positions or vertical positions also when we are considering about the uh, building feature heights and all these things. So these are two types of misplacement there are. So in terms of that also, it causing error in GIS handling with any vector dataset or raster dataset. Mismatch in spatial and attribute data. What happens when we have spatial data of the any feature of, like as I told, roads and building or agriculture land, and what happens, we have attribute table of the data set, but because of another coordinate system or because of undefined features, that spatial data what we are mapping over the GIS software and the attribute table data are not matching, because we made or surveyor or from where we collected the data is wrong. So that may cause mismatching of attribute or spatial data. Means what we are seeing or what we are calculating in terms of tables or what features we are dealing with, it is showing different output. So that is also an error in the GIS dataset. Human error in digitizing. Like as I told, human error in digitizing, it's same as the misplacement of horizontal boundary also. Like as I told, digitizing, we are digitizing any point or any building or any road feature or any water distribution network. So what happened, we deviate from one point, like 2 meter deviation we it has arisen, like when we compare with the OSM or Google Earth imagery. As I have showed you this digitization or this thing over this Bhuvan website. I showed you how to locate one road line and measure the length. I did not show you on GIS software, but I showed you in that Bhuvan website. You can see my previous lecture videos. And then this is called human error in digitizing. That is also an error in data source in of GIS. And then classification error, like what happens, I classified water feature uh, of through digitization some other area, you classified some other area, but both are not falling on the same reason as it is showing in Google Earth imagery or OSM. So it is also an, like you classified another reason over the same space, I classified another reason, but it is not correct. So classification error, this is called in the terms of classification error of the feature or thematic map. Or human bias, like as I told, surveyor locating point or getting the primary information, or demarcating into the attribute table of the same feature. So it is called human bias. As I have described all these three probable sources of error: measurement, like instrument comes as an instrument error or a surveyor error. Measurement of instrument due to surveyor or measuring by our own self. So that is called probable source due to measurement. And
Ma'am,
sorry.
ma'am, sorry to interrupt. I have gone through the all the this week's lecture videos.
Okay. Okay.
If you can, then can you please explain me the software QGIS software instead of this week's progress, because that will be helpful, because I mean there is nobody else here, so if you can do that, that will be helpful.
Okay, let me complete this topic because as we have told, we have to follow the assignment problems first, and then later whatever time is remaining, I will show you this errors how it is causing, because mostly on data sets and quality and the error causing. So I will try to locate you how the projection system is causing error and how the digitalization is causing error. I will show you one map through georeferencing and projection system, then you will be able to understand this and last thing sir has covered about this mapping and this cartography. So that also I can show you. I thought I will take this lecture in my next week so that people will be aware of this cartographic features and all these things. Okay, this video will be available for all. Okay, so this data encoding and data processing is considered as the uh, like this is on the geographic surface, a spheroid, and what kind of classification it has been considered. So that is depends upon the projection system mostly, like from 3D to 2D, as I told in my last class. Data error propagation or cascading is one of the data sets or others. Like we are using different data sets. So what happens? one one kind of error propagates into another dataset or another theme layers also, so which will gives overall wrong output. So that's why this can be taken care. So this is also a source of error. So sir told about confusion matrix. uh, I will give you one example over that also. The correctly classified user accuracy is defined as the ratio of correctly classified pixel divided by row, total number of rows. And the producer accuracy is defined as the ratio of correctly classified pixel divided by total number of columns. And overall accuracy is the ratio of correctly classified pixels. Means you have classified these many pixel for road network, these many pixel for water body, these many pixel in a raster for agriculture land, this many for residential area. So these are the classified pixel. So we have to have the count of this pixel like vegetation or soil and all these things, and then total number of pixel. So I will give you the example. So this is called the overall accuracy. Accuracy speaks about how much you are capturing the exact data on the ground of the ground surface in the GIS software. Uh, Actually, I want to know what you want me to explain in GIS exactly from this week lecture. Can you let me know? Hello, are you there? Nischit? Okay, I'm continuing. Uh, okay, you let me know whenever you come back. Okay. Considering the image commission error for the urban class, so let us see the example over the confusion matrix. How the commission error will be causing for the urban class. It would be like we have land use classes of urban, vegetation, water, others. So this is the total of the columns, and same these things are classified. So as we know, the rows deal with the user classes and user accuracy, and the column deals with the producer efficiency accuracy. So here if you see the urban having 850 uh, 850 pixels, vegetation is 12 pixel, water body is 30 pixel, and the total and others is 36. So row total for the urban is this much, 928. Similarly for vegetation, urban is 19, uh, 19 urban and 810 for vegetation, exactly it has been. And here if you see water body 650 and for others 850. The total of this rows and column is 3486. So as I told, the confusion matrix for user accuracy, the correctly classified pixel divided by row total. So for urban we have to classify here. So what we will do, the urban pixels which is 850 divided by, so as we know error of commission is for urban class is equals to 1 minus producer accuracy into 100. So producer accuracy for urban class is equal to correctly classified urban pixel divided by row total. So correctly classify, if I see, it is 650 for the, just wait a minute. Mm, okay.
And instead of urban class, it should be water class, no?
Yeah, it should be water class. Yeah, it shouldn't be. It's a mistake, just a typo error. You just make it mark. So it is, I will correct and I will upload this file. So it should be a water class. I was asking what you want me to explain in GIS software.
Yeah, yeah. Sorry, ma'am. I might be having some internet issues, so I
Okay,
might have.
okay,
So, ma'am, I just wanted to directly jump into working on software because
okay.
whatever sir is explaining, those are all like definitions
Theoretical.
and
Huh.
theoretical concepts.
Yeah.
So if I get to know how to work on QGIS software directly, like importing data and writing query lines for multiple the characterization of map, like how to extract data from whatever map we have. So how to
Okay,
write query lines for that, that will be helpful.
okay. So, have you seen my first class where I have told about actually that is sound problem in that, but the video you can able to follow the steps I have went through the different open source website and how to collect the data. First I told. In my second class I have showed you how to import the vector data sets into GIS and the raster data set. And in first class I have collected the DEM digital elevation model from the open source data which is from Bhuvan's website. And then what I did is a grid based data, two grids I have downloaded. And in my first class, I have showed the first or second class, I have showed you the LULC classification from that same website, Bhuvan. And I have imported this vector or raster data into GIS software. That is in the last minutes of the video, 15-20 minutes of the second lecture. You see how I imported this polygon and shape files, these things, and then how I have showed you the attribute tables and all. In this lecture, Shah told about the mass and cartography and the features. I will tell you that also. But the thing is, as per have informed to us, as Sir is going on, we have to help you guys in the problem solving sessions of the assignment. That's why, from my end, I am telling you the tools and workings. So, okay, I will let you know. Don't worry.
Okay, ma'am.
Yeah.
Thank you.
Uh,
Because I missed first and second class. I actually started listening from the previous session, because
okay.
second session I thought it was at 8 p.m., so I joined at 8 p.m. late.
Okay.
So I'll just go
It's
through
okay.
first and second.
Videos are available. Link has been given in my slides. You can go through the videos. What you asked now, the two things: how to import this data and collect. First video, it's having sound problems, so you may not be able to hear. But if you see how I have gone through the website, I spoke all the things. Actually, that lecture was very effective for all the students who have joined. And then second lecture, lastly, I have imported the data sets. Very few students were there, but you can go through that. Okay. Okay.
Okay.
I will tell again if a few more students will ask. No issues. I will import and I will show you how to get these data sets in QGIS and how to work upon it. Okay. What you are asking for. So
Okay.
then here this confusion matrix helpful to see the accuracy how the ground truth information have been located in our GIS tools. So what I am doing here, that is commission error for water class, it is taken care. So there is a typo error, not an urban class. So error of commission is 1 minus producer accuracy into 100. So producer accuracy deals with the rows, the total number of rows. So we can see here in this table for water 650 is the raster pixels, and the total rows is 753. So I have solved this problem for you people. 650 divided by 753, which is giving 0.8632, and multiplied with 1 minus this multiplied with 100, it means the error of commission for the water class, it is 13.68. Similarly, can you let me know the omission error of omission which is for the same water class, 1 minus user accuracy into 100. So user accuracy deals about, as I showed you here, the user accuracy, it is 1 minus row total. I will check this slide again and I will then only I will upload. There is one mistake because of, okay. So user accuracy you please define similar way as I have gone through the rows for producer. You tell with column. You tell with the column. So 650 is the exactly raster. So we have to divide by,
707.
yeah, correct. Then we will get the this here it is showing user accuracy, but it is producer accuracy because it deals with the column. And then the opposite, it is omission error. Omission means uh, we are not going to take into account, means 13.68% it is a wrong calculation. I will correct it and then only I will upload. There is no pointer or else I will be correct the solution. Wait. Okay. So this should be user accuracy, and then it is opposite actually, that is error of commission should be this formula is correct, but the only thing is Okay. But the only thing is I have taken into account the user if accuracy formula into the producer accuracy. I will correct it. So it means you understood what about commission and omission error.
Yes.
Commission error, what? Commission error tells about?
Uh, it basically is the ratio of the urban pixels with respect to column, and omission error is basically, I mean, one minus the urban pixel divided by the column, and omission error is basically one minus urban pixel divided by the row total.
No, no, no. I am asking about. Someone is asking to join. Just a minute. Okay. Okay. No, I am telling. Okay, let me correct this here itself. So this is water plus it would be this much. So I am telling the commission error here it should be not row, it should be column. Okay. Are you able to see my screen? Hello.
Yes, ma'am.
So this is the water class. It's not urban class, or we can say we can use the urban class pixels, and we can say okay this is urban class one. Okay, like here. Okay, you guys can please calculate. I will tell you this two formula. So this is user accuracy. First you calculate these three accuracies of the same example, then you let me know what are the calculation you are getting, what are the answers you are getting. Okay, so this is the formula for user accuracy, producer accuracy, and overall accuracy. So tell me the correct classify pixel for the water class, or you choose which one you want to solve for the urban class. Tell me for the urban class. Okay, user because the question is on the urban class, then I will tell you about the commission error or omission error. So okay, I'm describing here the commission error means what we are taking care. Okay, omission error is what we are discarding or avoiding, omitting. Okay, so that is the difference between these two. That's what I asked you. So you are telling about the formula. So user accuracy tells about the correctly classified pixel divided by row total. Can someone please tell me about this urban class? What it would be for the user accuracy, and I will be writing. Okay, user accuracy and producer accuracy. Okay, so user accuracy or urban class is equals to, it should be correctly classified pixel divided by row total. So here if you see correctly classified pixel for urban is 850. Okay, 850 divided by 928. So how much it is coming? Can someone please tell the calculation?
0.9159.
Yeah. So it means no, it is coming 0.9159. So it means we are able to capture the ground truth reality uh, around, if I calculate the what is commission error for urban class. This is the user. So commission error will be, okay, this is user accuracy. What about producer accuracy? Tell me.
0.943.
For the same urban class? Okay.
Yes, ma'am.
Okay. So how you have calculated?
850 by 901. Column total.
Yeah, column total. Correct. So how much it is coming? Point?
9433.
Okay, 0.9433. So around 94.3% from producer accuracy. And the commission error for the urban class will be 1 minus,
1 minus user accuracy.
no, 1 minus producer accuracy. Formula can't be changed, na? Formula is correct. I told you here. I will correct the slide. It doesn't mean my formula is wrong. Formula is correct only. Here I have taken row in terms of column. That made this user and producer confusion. Okay.
Okay, ma'am. So
Yeah.
it is 1 minus producer accuracy.
Yeah. Formula is same only. Correct. The error of commission error for the urban class 1 minus producer accuracy into 100. So tell me the answer. What it would be.
5.6%.
1 minus 99.9433. 5.67. Okay.
Yes, ma'am.
5.67 percentage. So we can say like from the error avoided by the data source from where we have collected, it is around 5.67 percentage. So that is the commission error for the urban class. This will be the answer. And then for water body you can check the same thing. Like that you can perform. I will correct this slide also, don't worry. So this is omission error means okay, this much we are considering and how much we are neglecting. I will check the formula which we are having some confusion over that, okay, before uploading the slide. So Cohen Kappa, this is also one of the things sir has covered that should be taken care. Cohen Kappa expresses the proportionate reduction in error generated by classification process. See, mostly whatever we are taking data from the open source data set, for what purpose? To demarcate our own reason of interest, to specify our own interesting feature. Like if you are interested in land use land cover planning and I am interested in medical facilities allocation, or I am interested in soil feature characteristic, geomorphological feature, or water networks, or industrial you can say what we can say industrial expansion, or someone is interested in transport road network, where is the highway, where is national highway, state highway, where is village road, such kind of things. So what we used to do with this kind of information, we demark, we classify. So our aim is mostly the classification of the different feature over the earth surface for our own interest reasons, for our own interesting features. And we will be allocating, we will be seeing the attributes of the particular feature. So what happens when we are taking the ground truth reality in the GIS software? We are we are we are maybe proportioning some error. Means like what from where we are collecting the in raw data means the open sources, how much accurately it is speaking about the ground truth reality. And when we are importing this data sets into our GIS, how much we are able to demarket properly or classify properly. So in between these two stages we may there may arise lot of errors which we may not be aware of. So to handle such kind of errors in the GIS tools or working, we need some corrections, or you can say the reduction in error. So the Cohen kappa coefficient express the proportionate reduction in error generated by a classification process compared with the error produced by a completely random classification. Like you are aware of such features on the ground surface, but another person who is not aware of this GIS things and all more better way, they will classify randomly in any other number. But how the observed and the like the other random things, how the observed and the exact things have been classified properly or not, this kappa coefficient helps to reduce this error, and it will tell about how much error you may cause from the observed accuracy or from the chances of agreement of error arising. So this is the formula of kappa coefficient. And I'm talking about the topology error. So if you think, whenever we are digitizing, we mostly digitize lines, points, and polygons. which are the vector data sources. So digitization tools help in deal with this vector data sources mostly. We have raster imagery. We want to digitize any feature, as I have spoken, as I have given example. So can you please tell about your interest of work which you want to do in GIS? So I will give the example based upon that.
Satellite imagery, ma'am. Basically remote sensing and mapping water bodies or seawater intrusion inside the mainland.
Okay. So you're talking about from the satellite imagery that is called the data collection, which we are collecting from the open sources like Google Earth Engine, or you can say Landsat imagery or Sentinel imagery, or Bhuvan is also one of the source for other classified images, thematic maps, and all this thing. You can go through the website. You will see my video. You will be able to see 4 or 5 platforms I have told, and I have collected the information how to go and which interest you are having, which option you have to select. So you can look into that. So I'm just telling whatever you told about the remote sensing data sets. Whenever we are downloading this data sets and including in our GIS software, we are demarcating, like you told, na, water body or any drainage network or any industrial reason or any agricultural land or any soil profile reason or any like you are telling about saltwater intrusion. It mostly happen in coastal areas. Okay, someone is asking for. Okay. Okay, sorry to interrupt. So, as I have told, like we have to demark it. It means we have to generate lines, points, or polygon. So there are error in topological error. Topology means on the Earth surface. Topography means you can now what we call, how we call topology or topography. Topography means on the earth surface features, and topology, when we are studying about this feature on the earth surface, means we are demarcating some regions. We are demarcating, okay, this much area covered by coastal or seawater, this much area on the land surface. So how the exchange is happening, or how much the water stream is allocated or delineated into this land, and how it is passing through this watershed. And okay, this many reason is inundated, or this many reason is drought reason, or this much agriculture land can be used for this is fertile for agriculture, or this is barren land can be used for other urbanization or some more building planning and all these things. So we used to demarcate mostly in GIS. Our work is demarcating, mapping, digitizing, exactly georeferencing, calculating the area, calculating the change, see the changes in satellite imagery, raster or vector datasets, and their calculation in attribute table and their futuristic things. That's what this week lecture is about, data qualities. So when we know about the data models, as I have covered in my first lecture is about what is the GIS to overall and what are the applications. Second lecture I have told about how we will work in GIS, how the GIS softwares are, how many, the open sources, how we collect the data and all. Third, I have told about the data sets, data models, how we work upon this kind of data model. What feature can be demarcated with the vector data structure, and what feature can be helpful to understand the raster data sets. And what are the projection, datum, coordinate system, and how to work upon this thing. Then only with we have this three lecture basics now, then only we'll be able to jump into this GIS working. So that's why. And then when we do digitization, polygons, mapping, cartographic things and all, we may there may be arising some error, as I have told, from importing the dataset to the working on the datasets. So we have to reduce the error to get into a desired output which is having a good percentage of accuracy. So this this can be avoided, like gap between the polygon. What happened when when we digitize now? So there may be, when we did not snap the tool properly, it may cause gap between the polygons, unclosed polygon. What happened when we did not zoom in properly on the OSM or our imagery, that Google satellite imagery? Then we we missed the nodes, so that may cause unclosed polygon or missing polygon. What happened when this all arises through the like you can say topological error. This is a topological error, but the polygon attribute doesn't come under topological, the feature which we are demarcating. So GIS map topology defines means rules and the behavior related to the geometry of points, lines, and polygon. Basically, vector features, as I told. So, topology is used to ensure the data quality, data compilation, preserving the spatial relationship between the data sets or the features. I will tell you once I do these things on the GIS. So, for mapping, for mapping anything, we need to know the map graphic symbols. Like every features, whatever we are demarcating from our satellite data or from our raw open source data in our GIS tools or software, we need to know the exact symbol so that we will allocate the things properly. Because selection of accurate map symbols is very important to to understand better way. Like you prepared a map, you located arrow like north arrow in different uh, way, and you prepared legends and these things. I will tell you this, these are the components of cartographic feature or mapping feature. I will tell you that also when I do QGIS mapping thing, okay, layout mapping. So it is having some symbol. Like when we speak about map graphics, we should know about the six things like size, shape, color, value, saturation, and orientation. Like what should be the size of the variation in length, area, and volume of the symbol. Like as I this is taken from the lecture of the sir only. So how, what is the size of a point? Like to allocate, like see, sometimes what happens, uh, we are having a you can say we are having a important location, we are having small residential area or hospital area, or we are having a big monuments. Like if you see in Gujarat, this Sardar Patel monument is there. So which feature is more important or which feature is less important? Based upon that, what we do, the variation in their sizes. Like for road network also, we demarcate highways, national highways, state highways with a bold thick lines, and for normal road line we will take a thin lines or dashed line only. So that is called demarcation of this feature. What should be the size of this thing? What should be the shape? Shape means appearance in the form of symbol. If you see in any open street map, you'll be able to see how the temple symbol is, how the school or colleges symbols are, how the any industrial symbols are. So shapes speaks about the appearance or the form of a symbol. And the color view tells about the dominant wavelength of the light in the visible section of the electromagnetic spectrum. For that, you please go through what are the electromagnetic spectrum or which feature will speak about this. What is see, we have the range of zero point 0.4 to zero point 0.7 nanometer to visible electromagnetic spectrum. So wavelength. So what are the dominant wavelength of electromagnetic spectrum? We are visible. We are able to visualize with our eyes or on the map which color should be taken care to demarcate such kind of feature. Like water, generally we usually take blue color. For urban land area, we used to take red color. For agricultural land, we used to take green color. So such kind of which color hue we should select for as per the dominant wavelength spectrum, because this feature reflect such kind of color when the any satellite imagery is going to be captured, this land surface profile or the feature. I will show you one Google satellite imagery, okay, to understand this. And color value is the denseness of the things. Like if it is forest area means dense plantation will be there, so I will show the dark green color. If it is agriculture area and there is a like man-made or proper land area should be taken care, so I can go for a medium green color. Or when it is a shrubland or normal grasses, I will show the light green color. So that is also called the denseness of the any feature. So the color value density, the color saturation tells about the intensity or purity of single hue. I will tell you what is hue. So it tells about the saturation, means how much like if I tell exactly a river basin, so I will demark it with the blue color, like dark blue color. If any stream is there, stream means normal stream, any nearby stream of the river basin, I can demark it with the light blue color. So like that the purity of the hue, purity means like if you demarcate any nala or any contaminated water area or salt water area, you will demarcate with a color of dark color. Okay, like you seen a nala and such kind of area, contaminated area will be brown color or black color area, water body. So that showed the purity. If it is pure, it should be brighter color, or if it is not pure, it should be darker in color. So intensity or purity of the single. Orientation is the direction or a angle of the rotation of an entire map. Like as I told, there should be a north arrow to understand. Okay, this is the map of India. In that Indian map, I am selecting this state, this district, or this region of interest I am having, and in that interest, where is the north, where is the east, where is the south, where is the west. So this direction should be clear to make people understand, okay, we are heading towards this direction, and I am able to understand this is the physiology of that area. There is the saltwater intrusion near the coastal region, and in the northern region of this study region will be fertile land, because there is a proper water channel, and the southern region will be, so we can able to demarcate such kind of feature in our map easily if we know about the direction. So orientation is also a matter of map geographic symbols. So next, some important points are also there, like line specification and line densification. Line specification is performed by removing additional points. Simplification, sorry. Line simplification is performed by removing additional points where we don't need additional road network, or some roads are going to be dead end or something, we need not to provide, so we can remove such lines or additional points which are not taken care much. Line densification means adding new points in simplified interval via mathematical function. Sir might have told it in detailed way, I'm just telling in a brief way. Swapping is, sir told about some geometric transformation. So in that, we used to do spatial manipulation, data manipulation, transformation. So warping is a type of geometric transformation and manipulation. It includes one data layer to another. For the instance, classify satellite imagery may require warping to fit an existing state use land use layer. So I will tell you how this thing has been performed. And I told hue represents the dominant wavelength of light, and intensity represents the total brightness of the color, as I have told you in our last slide. So uh, please try to look into the digitization and error, and how to locate this ground truth reality using the digitization tool which is there in QGIS. Like I'm working over open source quantum GIS software. Short form is QGIS. So when you demark it, then only you'll be able to specify different features, and what the classification we are talking about, and the error associated with that in the attribute table or a spatial scale. So okay, this is my YouTube link, as I have told you. This is my YouTube link. You can go through that. Okay, I will tell you the QGIS thing, one importing one imagery, and you'll be able to understand these things. Okay. So let me open one new. So this is my QGIS software. So as I told you in my last class, these are the menu bars where we can save the project or open new projects. And layout is also there where we can map our what are the things we are demarcating here in this working window. And then these are the edit tool. When we start dealing with the raster or vector things, it will be active. So now it is not active. So you can see here this ring, add ring, this all are the digitization helping tools. So editing tool. And here this is view any map or whatever things you can use pan that, like we have this hand now, you are able to see this pan, so you'll be able to locate any map with this pan. So these tools are also available here, so we can select and we can directly go, no need to go through direct main menu bar and then select one by one, directly choose that panels and these things. So these are the toolbars, these are the layers, whatever layer. So whenever this is the very important tool menu of this software is the data source manager. Whenever we have to import any data, we need this data source manager. So I have selected we can select browser where we have allocated our like C drive, D drive, where you have downloaded the data. Vector, we have to go through vector dataset, we have to locate the file where you have selected, where you have demarcated your vector data, and then bring it here. So when you, okay, let me open one, I will tell you. I did not locate here. Okay, okay, let me bring one okay, I'm bringing one vector file, shape file. See here, it came or not. So this is one, just simply I just showed you one vector. This is a polygon, rectangle polygon. Here I showed you. So like that we can bring raster also. I have raster datasets. So raster is kind of JPG image or TIFF format as I told you. So I can bring a raster also. Open this software. Wherever from where satellite datasets we have collected, we can bring this. So when I bring this raster, this is the raster image. So what we can do, this is, see, this is moving now, this is very small. So we can scroll also, zoom in, zoom out, or we can select on this raster data, we do zoom to layer. So it will be, it will come in front of, in a as larger as it can appear on the screen, it will come. When we select and right click, zoom to layer, it will come in front. So this is one raster imagery. Like that we can import any dem file also, and we can demark it. I will show you one dem file also. Wait, what else I was telling about layers? So remove layer or duplicate layers and these things we can do. Settings, someone is kindly, email id. Okay, I have mentioned my email id in my ppt. See here, akanksha c.e.07 @gmail.com. Please look into the slides, you'll be able to get this information. And then so these are the, like raster or vector I just imported. This is simply I have this raw file, so let me import one dem file. So see, same layer which I have imported from this data source manager, this the icon, you see this icon, same icon. So I'm going to directly select this icon. It is asking for dem file allocation. So like that, let me download one dem file. I will show you how to download, or you can go through in my first lecture. I will open one Bhuvan, ISRO Bhuvan platform. Okay. So open data arc. So there we can get the open source data. So we, Raj, you are seeing these things. You asked, no, these things.
Yes, ma'am. Yes.
Yeah. So from the Bhuvan open source archive, we'll be able to see the satellite or sensor data. Or see, when we need any sensor data, there is, I told you there is four or five kind of resolution. 23.5 meter resolution, which is cartosat imagery. Just a minute, I will tell you exactly. So in Bhuvan we have five resolution. One is iris, like Indian remote sensing institute satellite imagery, which is 55-meter resolution. So if we see over the globe in India map, so that is 55-meter resolution. And then list 3 imagery, which is, see here, list 3 imagery, resource set to list 3 imagery. When I select, see, you'll be able to see the 23.5-meter resolution. This data set resolution is 23.5-meter. So I just zoomed it, so it came like that. So this is list 3 imagery. List 4 imagery, it it gives you the information around 5.8 meters resolution. And then cartoset, if you see, this is 2.5 meter resolution, more finer than list data sets. And cartoset 2 is 1 meter resolution. So like that, we can we can select, but no need to go with this resolution now. First we will get one information of simple ocean set imagery, and then okay, so I'm interested in this data sets. First we have to log in, or else we can't download the data. Last class also I told we have to log in, then only we have to prepare a register. You have to register here, and then you make your own profile so that you'll be able to download data, because you can see data here but you can't download until you log in. So that is needed. So I want to, okay, with asking at the end of the session, kindly go the first slide. I will note down your email ID. I will share, Raghu, I will share my this slides on the page, so you'll be able to see my email ID. Don't worry. Okay. So see, I'm interested in theme products because I can import these themes in my GIS software. So what I will be going to do now, land and terrain information I want to get. So the product will be our, okay, I'm selecting one Cartoset dem version R. See, Cartoset imagery open. So here, if we know what latitude, longitude we know about this information, then we can directly point here. See, are you able to see the bounding boxes? So we can go through these things, and we just mention this latitude, longitude, minimum, maximum, and then we select this region, and then we'll get the information of the land and terrain. Or else I don't know my latitude, longitude, I want to randomly select in a one region, one tile to work upon. So what I'm going, map sheet I'm going. So when you go to map sheet option, see here this left corner, map sheet option. So for that also you should know the topo sheet number, because each I have showed you in my last class now, the topo sheet Bhuvan having the survey of India, our having this topo sheet numbering for particular reason, that also I don't know. So I will go for tile. So what I will do, when I click on start, it will ask to select the tile. See, it got selected. So I'm interested to select this, maybe Maharashtra region, I guess. Maharashtra region. So I am selecting this tile. Okay. And stop it when you select. If you want to select more, you just give control key and you select another tiles also. Okay. Another, this tiles. This tiles. So another more tiles you can select. So I am interested in one tile only, so I am selecting one tile so that easy to work. More tile if you select, it will take more time to load on your QGIS software and to see any results. So better I will go through this and then stop, select stop, and then next. So see, you got this topo sheet number D43J, bounding box. This is the latitude reason. Metadata means the data of the data, what data we are going to work upon. So select this metadata, you will be able to see, as I told you in my first class. Here the Bhuvan is giving the data of, this is C1 is Cartoset 1 dem 16b to, this data is of year 2008 to 2012, version 1. The theme is what information it is giving is terrain information. And the keyword means this is the Cartoset 1 dem stereo data of India, ISRO. National Remote Sensing Center they have brought this satellite imagery. They are working on these things. Access consent, registered user only, then you have to register on that website, then only you will be able to access this data. As per the, so what more is needed? Status, this is the dem in progress. And city, mailing address, this is the information of whoever collecting this data. The spheroid or the datum I told you na, geographic coordinate system, because it is giving the information over the globe of 1984 WGS. If you have taken my last class, I have told about what is WGS 84. It is geographical coordinate system 1984, which is worked universally. So everyone is following this projection system. And this, what more? One pan I have selected, having cartosat having resolution of 2.5 meter, you can see here. And the resolution I told, okay, okay. So here you can see what sir is talking about. Accuracy also last time I showed na. This image I'm not able to see. So this file format is geotiff. Geotiff is the file format of which kind of data? Raster or vector? Can anyone answer this question? I told you in my last class.
It's a raster data.
Yeah, yeah, correct. So it's a raster data. So it is 16 bit. 16 bit signed. This is Cartoset having good resolution of 2.5 meter. So it is having 16 bit signed integers. Information means if you go zoom, I will import this image, then only I'll zoom in QGIS, I'll be able to see. So view will be able to see, this is the, see, when you view, you select on view, you'll be able to see this dem. See, this is the dem. And when you select on download, so it is downloading. See here, it is downloading. So I have downloaded this style. Now I am going to import this style. This is a satellite image. So okay, let me open my download. I'll make a folder of dataset. Okay. So I have down. This will come in a zip file only. Okay. So you have to. I am just allocating a path so that I am not. So anytime when you download any data from satellite or we're working in GIS or any other software, you please don't locate in C or program file or download section, because if you locate D drive or E drive, then only no error may cause, because sometimes these softwares are in your program file or C drive. Sometimes it may cause error. So better you follow your own path of D and E drive or any other drive other than the program drive. So what you will do, you extract this. I'm extracting here this information dem. So I got this dem file. Now you can see here it is having the TIFF file. So what I will do, I will go through my QGIS, new data source manager, raster. We have to select raster. If you select vector and go and select your raster, where it is, let me locate this file, datasets class. So I'm selecting this raster, open. So you are selecting this vector one and you have selected your raster. So what it will throw? Error. See here, it won't bring this image here, it will throw error. I'm removing this layer, unnecessary it is there. Then what I will do, I will select raster, whatever type of data you should know, then only you will select the exact data source manager, and then you select this TIFF file. Then you add this layer. See, you'll be able to see this layer. And if you want to see this layer on the earth surface, as I have showed you here on Bhuvan with this background imagery, I will give you a trick. So where is that? Okay. There is web. If you see here, when this is QGIS is the open source software, everyone knows now how to download QGIS. I told in my previous classes, two classes. Please go through them.
So
Huh. I told latest version is 3.28, but try to download earlier version, because sometimes latest version throw more error because it is more advanced and it is having another algorithm. So I used to work on like previous version so that no problem I can commit. So till
Madam, 3.16, I think it should be fine
yeah,
right now.
3.16 is the best version till now.
Zurich,
Yeah,
Zurich.
Zurich.
Okay.
So you can download that version and you start working upon it. See how the features or the tools are. See what are the see. If you need more tools here, like I have this tools here. If I want to, digitization tool is there or not, I don't. Okay. So if you want to bring, you have to just select this. Right click here. You'll be able to see here digitizing toolbar is there, like as I am telling about digitization error and this thing. Shape digitizing toolbar, snapping toolbar. If you on this now, then only you want uh, uh, like when you work on digitization and all, you are not supposed to get error in this snapping tool, because what happens when we didn't on this snapping toolbar and select this snapping option, we will be as I told na, same lining or it happens like it won't locate you the exact point. Snap will helpful to select the vertices easily for the area or the boundary. So it is very helping tool actually. So you won't arise any overshooting or undershooting or this dangling, this kind of errors in your digitization. So these things are very helpful toolbars. Okay. So what I'm going to do, I have downloaded one DEM terrain information of Cartoset 2.5-meter resolution from the Bhuvan website, and I imported these things from using this data source manager raster and in my QGIS software. Now I am willing to just locate the same thing. See, I have Bhuvan, I have downloaded this, that's why I have Bhuvan Web Services also, open source layer. So I want to see the Google satellite imagery in my map. This I have added in my QGIS. So you need to know how to add. Okay. So for adding any satellite imagery in your QGIS directly without going to the web page and like I have gone to Bhuvan, I can go through Google Earth also. I will show you Google Earth engine. Okay, Google Earth engine. I will go and I will show how to. There also you have to sign in, yeah. Okay, platform datasets. So this open source helpful to, these are the datasets of Google Earth Engine. Okay, I'm not willing to wait just a minute. So this is the Google tool, that's why it is available here also. See here, Google Earth. It will take some time based upon our internet connection. See, okay, I want to go through the, so this is, I have logged in, that's why it is showing my profile and these things. You can also see when I select on this globe, see here, it started showing on the globe. Then what you have to do, you have to go through our Indian region. So I'll be zooming and rotating it. Left click and try to move this cursor, or else from here also you can locate. See, you're seeing the right side corner. I am moving this globe from here, locating my study region, going through. Okay, there is a hand pan used to come. You have to move. Just selecting. Just a minute. This is open na, this is online thing na, so it will cause, or else I have software better, I will work with this. So you can download also in your system like Google Earth. I have downloaded Google Earth to get the data. No need to work and hang like this. You can directly demarcate your reason and you can directly see the things. Okay, let it open. It will take some time actually. So what I did, so better to work upon these things. I have told you in my last class how to bring. Just Google it. Your Google satellite. Google satellite imagery in QGIS. So you will get some link. I will show you. See here. How to add Google satellite imagery and Google Map to QGIS. Right click over there. When you open this, you will be able to get this URLs, products and URLs. Are you able to see, guys? Guys, you are following me. Okay, then. So like that, you just follow this link and you have to go through your data source manager and
Ma'am, I think we can make use of HGMGIS plugin. We can use all kinds of base maps in this.
yeah, plugins only. This URLs are giving you plugins only. That is the easier way. That is
Uh-huh.
also okay. What you
Because
told.
I've been
Yeah.
using this HGMGIS plugin, ma'am. I think
Okay.
base maps, you have a lot of base maps, Google
Yeah, yeah.
Maps, Google
See,
Satellite,
I also
everything
have
is
these
available.
things, but whoever not knowing, for them only I am telling. Na?
Okay, ma'am. Sorry,
So
sorry. Yeah.
it's okay. It's okay. So now I got this Google satellite imagery here. You can go through plugin. You can, what he's telling is also manage and install plugin, and you can select this. Which one you are telling? Let it open. Raj?
Not me, ma'am.
Okay.
Uh, but the other person was selling HGMG or something.
HCMGIS.
Is it there in plugin?
Yes, ma'am. Yes, ma'am.
HCMGIS.
This one, this one.
Yeah. This also you can install. See, I okay. So for base map for the open data sources, you can bring it. But I already have imported this URLs and the things which I was speaking about. So this also gives you all Bhuvan and Google Satellite and OpenStreetMaps things. So you can go with easier way to understand. This is also fine. Good. Let it install. It may take some time in my system. So see what I did. I brought Google Satellite imagery and it's not showing here. What is the problem? Yeah, not interested to see this message. See here, the style came as Bhuvan. We are seeing same location. So if you see the information of this style, so just a right click over there, go to property information. The same information it is. So you can see the CRS coordinate reference system. It is EPSG 4326 WGS 84 geographic. It is not projected. So to work on digitizing or georeferencing and to calculate the feature or the digitized area, you should reproject this to the projected reference system, which is UTM, Universe Transverse Mercator, which I spoke in my last class. So India lies under 42 to 47, I guess, this zones. So I will allocate these things, and how to allocate I will show you the how to change the projection. So here the information of this tile of height and width and geotiff file, and what are the statistics tells about the mean, medium. This is what, this is terrain information will gives the elevation, means the mean height of this raster is 522.54 meter. And then more information we can bring it. So other things are, this are one band means it's gray band. Sources is, this will tell you about coordinate reference system. Symbology is, we can change the color band. See, it has the single gray band. So I want to see the different color features, so it will be understandable. So now I have changed, but it is having number of elevation ranges. So what I will do, I will select the pseudo color will be the shade way of the same gray band. So I can change the type of this pseudo color. So I am changing turbo and this thing, and it is continuous. See, mode is continuous. We can give equal interval. Continuous means 0, 182.5, 362. The values of elevation lies in this way. So if we do equal interval, now you have to select how many intervals you want. This classes, there are 5 classes. So I want to select, okay, 5 is fine, okay. So equal, then again classify, then you'll be able to see it will be having equal interval. Quantile, if you do, it will come in discrete values, exact values. So that is also there. Or this is, you want to increase brightness of the image, contrast of the image, you can play with this things in this QGIS for better visualization. Okay, so I'll be going to apply, and okay, see here how it got changed, and see the ranges also. Now if you want to see the features to delineate anything, this is, see, this first I want to tell you about the reprojection, then only delineation I will capture in my next class. So I just have downloaded one cartoset image from Bhuvan, and I have allocated in my QGIS with the Google satellite imagery. Let me select another imagery. This is not looking good. Hybrid. Okay. Yeah. See, now it will be clearly visible to you people, I guess. See. So how it is showing the profile. If I zoom more and more, I am offing this style, then we'll be able to see. Google satellite gives very better resolution. See, we can, I told you in my last class, this is showing very good feature. We can zoom it. We can work upon these things. If we don't have tile also, we can use digitization shape files and these things to demark this. See, this is the houses. You can see we can demarcate this region. This is the water body. See, this is the agriculture land. How much it is appearing. This is the barren land. Agriculture land, how I am able to say this is agriculture land? Can anyone answer this question?
By, I mean, for humans it is by shape, and if it is a machine, by
Defined,
classifying it as a
defined
polygon.
shape, defined boundary it is there. If you go through another place where, see, this is the properly defined thing. So agriculture land, farmer used to demarcate, na? That's why
It's a
the
plantation, ma'am.
plantation. Yeah.
Yeah.
Or if you see, this is kind of random. This is like shrub land or normally forest. This is not forest, this is called shrubland, which is not agricultural land.
Yeah,
Okay.
yeah, exactly.
Yeah. This is this is drought water body. So like that, it is loading. Okay. So sometimes it may not appear, so don't worry about this. It is loading because we are directly bringing this Google satellite imagery in our QGIS. If you go see here how much greeneries are there, it means, and we can also see how the plantation is happening, or how the crop is going to be harvesting stage, or this color will appear. See, you can see the light color or dark green color. So it will appear the, see, this is the urban land. Let it come. See how much this population and this residential building you are available, road network. When wherever you will see the urbanization, you will see the proper road network channels and these things, because we need proper roadways, transport, and all these things. So like that we used to see. First, you do one thing. You bring any satellite imagery in your QGIS and you see the features. Then you can work easily when you started understanding these features. So what I do, see, this is my. I will do. See, it went like that, na, very zoom. So I just selected right click zoom to layer. It came the proper, like proper shape. And so this is the dem. It is ranging from 0 to 947 meter uh, elevation. And then what I will do here, I will see the projection system from the property. Okay, and symbology I told you. And then transparency means you can add some more feature band, how much transparent you can make, you can do. Histogram will tell about the band range. See here, just showing the pixel value, how many pixel of band. So it is having number of bands. The histogram, it tells you about the wavelength, electromagnetic spectrum, and these things. Rendering, metadata information about the data which I showed you in Bhuvan. So this all the information. You should know what these things are speaking about. The extent of latitude and longitude. That minimum and maximum it was asking now in QGIS to select any type. This is the information. Latitude and longitude. And then this is the dem. Now I want to change this projection system of this raster. So what I will do, go to the raster, projection, var projection. Because it is already in WGS 1984, you have to go to var projection. It will bring a, yeah. This is the dem you want to project. Okay. I'm offing this satellite imagery first. I want to work upon this dem file. So this is having it's need not to be changed. Target CRS. Source CRS is our WGS 84. Okay. Which is of this from the information tab. And now I want to give a projected coordinate system where I want to locate it, so that I will be able to work. So no projection, it ticked. So I will uncheck this. I want to give a projection. So which projection system I should go for? Anyone please answer?
EPSG 32643
Okay.
UTM zone.
So no. It won't catch. If you see here, it is showing the reason, red line. It is showing the reason which
Hmm.
is not lying. Our reason is this way, this way. So what I will do, this we will I will go through projected system here. If you see, this is projected coordinate system. In that, I will go to WGS UTM zone, which is on, I will select and I will show you. We went to 44N. Let me go to 43N. See here, it is catching this.
Hmm.
Okay. So what I will do, I will do okay. I selected this. This I have selected. Now I will do okay. It will bring this projection system here. Then I will go re reprojected. This file will be saved. So you want to save temporarily, you don't want to work further, so it will save to your program file. If you want to save in a particular location, save to file. I will locate my file here. Okay, just a minute. So in dataset class itself, I will locate my flight. This is what projected tile or dem. Okay. I named it projected dem and I run. Give a run. So it will take just a few minutes and it will show the task completed after completion. Let it finish. Yeah, see, completed var projection. Then you close this. Then you see, I will off this earlier image. Then it got projected. So it will be in another projection system. So zoom to layer, it is showing gray shade. So
ಏನಮ್ಮ ಹಾ ಎಲ್ಲಿ ಕಳ್ದಾಕ್ತೆ
what I will do,
ಎರೇಸರ್ ಇಲ್ಲ ಎಲ್ಲ
I will
ಹೋಗು
use symbology. I will
ನೆನ್ನೆ
obtain
ಹಿಡ್ಕೊಂಡಿದ್ದಲ್ಲ ಎಲ್ಲೋ ಇದು
single palette
ಇದ್ರಲ್ಲಿ ಹಾಕಿದೀವಿ ನೋಡೋಗು
shade and then
ಬ್ಯಾಗಲ್ಲಿ ಇದ್ರಲ್ಲಿ ನೋಡೋ
I will give any other shade to this,
ಕಾರಲ್ಲಿ
any shade you whatever you will like you can give, and then give OK. So now if you see the range of it came in continuous range, I want to change to quantile range. And with the see this is 255 because it is 8-bit image, so I want to give 5 classes only. I
ಚಿನ್ನ
can
ನನಗೆ ಗೊತ್ತಿಲ್ಲಪ್ಪ
do
ನೀನ್
OK.
ಕಳ್ದಾಕ್ಬಿಟ್ಟು
See
ದಿನ
here,
ಒಂದೊಂದ್ ತಂದ್ಕೊಡಕ್ ಆಗಲ್ಲ
this
ಲಕ್ಷಿ
is the dem.
ಆಗಲ್ಲ ಕಣ ನೀನ್ ಏನ್ ಮಾಡಿದ್ರು ಅಷ್ಟೇ
Please mute yourself.
ಸಾರಿ ಸಾರಿ ಸಾರಿ
It's
ಮ್ಯಾಮ್
okay, it's okay. So now you can see this is the dem of projected dem. Now you right click, go to property and information, see the CRS. This is 32643 WGS84 UTM zone. UTM speaks about the projected coordinate system. Now, wherever you will roam, you see here this coordinate system is moving. See 84. If you see here, are you able to see my screen? Here, down,
Yes, ma'am.
coordinate. And then scale is also there. And this is the showing which projection system you are in. So, like that.
So the coordinate is with respect to georeferencing or is with respect to the image, ma'am?
The coordinate system is with your raster. Georeferencing I will do when I have any JPG file or any image and I want to locate it on this Google satellite. See, this dem file I have collected from Bhuvan, na, from Google satellite. So this itself is on the globe. When nothing is on the globe, like I will bring one image. Wait, do I have or not? Last time we need to download one topo sheet, है ना? Maybe I don't have. I have to download one topo sheet to show you these things. Wait. Okay. You can go to Nakshe. You can go to. So I want to download. So topo sheet number I don't have. What I will do? This information is there, na? With this topo sheet number. I might have lost this number. Okay. Okay. I don't have number. So we can check also. We can select a district. I feel it is in Maharashtra. Not knowing. I don't want to go like this randomly. You should select a specific reason. So last time I have downloaded na Nakshe. Nakshe is also one website where we can download this topo sheet. Last time I have downloaded. I don't know where it went. So what I will do, first I will download one this topo sheet. Okay, I showed you na in last class. So after downloading, this will come as a PDF actually from this websites. I have to make a profile. This is Survey of Industry. It's not working. Okay, you just listen in coming class. I will let you know. Okay, so what I will do, I will bring one image here, and this is satellite image. This itself is on the globe. Okay, from there we downloaded this tile. But if we don't have such kind of image, or we have only simple map from Survey of India or any topographical map, what we used to do, we first did georeference. See here in that georeference tool is there. Okay, so we have to. Uh, I will tell you in my next class how to do georeferencing. So we have to locate latitude and longitude on from the map on the globe. Then it will come on the geographical coordinate system. From there we have to again convert this coordinate system to projected coordinate system, which is UTM coordinate system based upon the region it may fall in India. And then we'll be able to move for digitization and further demarcation or classification. This is the proper channel to work upon. This style I have downloaded from online satellite imagery. This itself is on the geographical coordinate system, which is WGS 1984, as I have showed you here. If you see, this is having WGS 1984. This is geographic coordinate system. But images or any map doesn't have this. We have to locate, so we have to do georeferencing for that. Then when I again georeference, then for getting information in our attribute table or digitization or demarcation, we need to project it. Then only we'll get to the information and the attribute table and the feature whatever we want to work upon with this image or map. So like that we'll able to do. And then after demarcating, we'll be able to play with the attribute table, we'll be able to see more feature, we'll be able to generate our own map. So this is dem. So now, okay, I am offing this two layers. See, this is the projected one. Zoom to layer. So I want to work with this. So but this is a dem file, this is a raster. Raster having pixels. See here, when you zoom it, you will be able to see the pixel size. Pixel, this we can work, we can play with this data, we can uh, but here we can't for mapping or for working we need to know some more feature or tool of the GIS. Like here you can see the processing toolbox here. So raster terrain analysis, raster analysis, network analysis. So for that you should know some more basic fundamentals, then only I'm not going with these things, that's why. So cartographic, so combine the dataset, print layout, topographical contouring. I want to do topographical contouring of this dem. So what I will do, input layer will be oh, my this projected dem. Okay. Number of colors you want? I want 5 colors. Okay. Distance between the feature it should be, I will tell 10 meter. And then I want to save this contour file in my same file. I will name it as contour. Because it is elevation data, it can generate contour. Okay.
Ma'am, the topo sheet number is D43J, ma'am.
Okay, you brought, you from where you got that?
I just repeated the process what you did in Bhuvan website.
Okay, that's what I thought to do. But then I thought, oh, video is there. You can go through that. What is that? Topo sheet number?
D43J, ma'am.
No, no. One more thing. One number might be there. D43J. Before that, something?
Nothing, ma'am. It just says
D43.
D43J and
Hash is
bounding
there?
box. No, ma'am, no hash. There is bounding box called 75E14N and 76E15N.
Okay.
So
Okay.
I think it is based on Bhuvan's topo sheets and it is not based on SOI's topo sheet number.
No,
Will
that
that
you
be
told
correct?
based upon grid, that you told based upon grid. But SOI, Survey of India, is having their own maps. You go through Nakshe. Actually, my Nakshe is not working. In that also, We have to make a profile to get this sheet, topo sheet.
So both Bhuvan and Nakshi have different nomenclature of data sheets, ma'am.
Numbering may change, na. Last time I showed you that topo sheet maps, na. So numbering may change. We can't rely on it. We have to select the district and the region that it was asking, na, in the token district and the state and the district. And from there, going there, we can demarcate. Better to work with latitude and longitude. Best way. Nowhere you can deviate.
Yes,
So
ma'am. Latitude and longitude, it is 75
uh,
E14N and 76 E15N.
okay. Let me finish this actually.
Okay, okay.
So
Sorry,
you
please
you
tell.
can you can play with these things. Okay. Will next time when I come, I will try to bring an image and I'll show you the georeferencing, and if time pertains, I will show the digitization also. So don't worry about this. Now you understand na, how to bring that Google satellite imagery into that QGIS and how to see the symbology. Actually, I showed you here the symbology. If you want to play with this also, you can see the palette unique color. You have to click on classify, so it will come. So now you want, see, this comes with number of range of elevations we have. So better not to go with this. I will go with, for elevation, hillside or single plated pseudo color is good option. So we'll go with any color, and we'll give a equal interval or quantile, because if you go with continuous, it will give number of elevations which you may not be able to understand. So better to work with quantile with
Ma'am,
your
what is the major difference between quantile mode of classification and equal interval in?
see, I will tell you. See, the continuous is telling with decimal. When you go
Uh,
with equal interval, this is also comes in decimal with with equal differences. Like, see, if
okay,
I change here 10 classes, so it will show you, see, 0 to 98, 98 to 196, the
okay,
98,
okay, okay.
98, 98.
It gives equal interval range. Yeah,
Equivalent.
yeah.
And
Yeah.
quantile will be their own classification with the definite values.
Hmm.
So as per, see, I have given 10 classes, I will give 5 classes, so they will define as per the range of elevation. So when you apply an okay, you will be able to see this. I changed this symbology color, so it appears like that. So no worries, you'll be able to see the, how you'll able to bring the raster, how we'll able to see the information of the raster here. What projection system, what latitude, longitude, what are the size or bit of this data type, geotiff, and what are the statistics, minimum, maximum, mean value, standard deviation, percentage valid. So it is showing, it is very good imagery actually. The statistics valid percent is 100%. See here. And some more information, you explore by your own self this QGIS software, bringing one raster and one vector, and see how you'll be able to work or not. Next class you can ask to any doubt if you want. And then I will try to bring an topo sheet, and I'll try to digitize and view reference first and then digitize. Okay, today's class I'm wrapping up, okay, with this. So this is my Google Earth I have opened. Okay. So thank you guys. So you can mail me if you have any doubt. This
Yes,
is my
ma'am.
YouTube link. I will upload. I will correct this file and upload this. Thank you so much.
So,
Okay.
thank you.
Thank you.